Okay, paper 2, question 8. We're going to go to a list and spreadsheet page, and we're going to type in the data given to us. We'll give the headings. I'll do x.months and y.psi, and we'll type in the numbers 0, 3, 6, 9, 12, 15, 18, 21 and 24 for the 9 values we've been given. And similarly for the pressures, we've got 39, 37.2, 35.6, 34.7, 33.5, 32.2, 30.6, 29.2 and lastly 28.1. And even though the question doesn't ask us to do it, it'd be a good idea for us to quickly draw the graph of this. So the way we can do that is to press Control-Dock to insert a new page. We'll go to Data and Statistics, and we'll just plot the months against the pressure, and you can see that no point's looking too out of alignment and is looking like a good fit. So we can just go Menu, Analyze, Regression, and we're going to go for a linear fit, a plus bx, and you can see the equation of the linear connection between months and pressure is given as 38.68. Subtract negative 0.445x, and you could round those to 3 significant figures. Now we've got a comment on the strength. Well, just visually it's looking like a very strong connection, but we can back this up with some numbers. If I press Control-Dock to insert a new page, and we'll go to a calculator page, there are a couple of ways in which you can get access to a number that quantifies how good this is. The first way is if we press Menu, Statistics, do statistics calculations and do 2 variable statistics, and tell it we're looking at the X list of months and the Y list of pounds per square inch, and then just click OK. We get a whole bunch of summary statistics, and the one that we're interested in is the value for R, and because it's very close to -1, it means it's a very strong negative correlation. Alternatively, what we can do is, if we go to Menu, Statistics, and we're going to do Stat Calculations, and we go for linear regression, so very similar to what we did on the data statistics page, but coming at it from the calculator perspective, and we can do the number of months against the pounds per square inch. It automatically stores the regression equation to F1. When we click OK, it gives us not only the value for R, but also the value for R squared. Alright, they're both very close to -1 and 1. This is a very strong correlation, and you can use that as the basis for your answer to part B. Now we've got to interpret the meaning of the gradient and the intercept. Well, let's just go back to the diagram. The intercept will be the value up there. Oops, sorry. Here's the y-axis here. The intercept, which is looking at 38.68, seems to be the pressure at 0 months. And there's 0.445 that's negative. For each 1 month that goes past, it decreases by that many pounds per square inch. So obviously we've gathered the data every 3 months, so it'll be 3 lots of that. But it's the rate at which air's leaving these tyres. Now, being asked to estimate the air pressure after 20 months, so just visually we go along to 20, then read up, and we're expecting something around about 29.30. But if we go to a calculator page, we can access it 2 ways. Because of what we just did there, if I press var, the regression equation is already in F1, and so I just do F1 of 20, and it gives me a value around about 29 or 30, which is what we're expecting. If I hadn't done that command, then the option stat regression equation contains exactly the same expression, and this should give me exactly the same answer, and it does. Alright, so depending on how you've gone about getting the regression equation and whether you've put it into F1 or not, there's 2 ways of utilizing the algebraic expression that's been found. Part F requires you to not use a calculator, but we can very quickly update everything here. We're going to make sure all the pressures are going to be 0.3 lower than what they are. If we go back to our original list, all the pressures were in the list called y.psi. So I'll go to a calculator page, and what I'll do is I'm going to press my var key to pull up y.psi, control template, and press var y.psi, and I'm just going to subtract 0.3 from it. Now when I do that, nothing will necessarily appear different on this screen, but if I go back to my data and statistics, you'll see that this number here is less than it used to be. The whole line has dropped down because all the points have dropped down, and the regression line has been updated there. And if I wanted to repeat any of these previous calculations, I could do so for the new value. But for part F, the regression equation, which you may have come back by without using the calculator, is the one currently on show. And we're done.